Hello, my name is Dmitry Bagaev, and thank you very much for the opportunity to present on the JuliaCon. I want to introduce for you a new reactive framework written purely in Julia and called Rocket. But before we'll talk about package itself, I want to introduce to you a general concepts of reactive frameworks and give you some background for those of you who aren't familiar much with this paradigm. It's quite a big topic to discuss in 10 minutes, but I will try to outline the core ideas that each reactive framework should consist of. One of the core ideas of the whole functional reactive paradigm is that instead of the traditional variables, you would operate on observables, which in a sense is a stream of data, potentially infinite, or it can be empty, it can be dynamic, asynchronous, it doesn't really matter. What matters is that you can react on changes in the stream. And most of the observables are lazy. It means that if no one is listening for its changes, observable does nothing. And normally at the end, observable send a completion event, but it also can terminate abnormally and send an error. Observable can be a timer, for example, or a current time, or a data from a server, or a signal from your mouse. Of course, it also can be a static data like an array. And the second core idea of functional reactive paradigm is a subscriber or a listener, or how we call them in Rocket, an actor. An actor essentially is an object which knows how to react on incoming data and may perform some actions. Then it receives a new message. The mechanism for listening to changes in an observable called subscription. And after subscribing for some observable, you're also able to unsubscribe from it if you don't want to listen to changes in a data stream anymore. Might be useful, for example, if you want to dispose the resources held by the subscription. And the most powerful part of reactive frameworks is the operators. They're like building blocks and indeed a very powerful mechanism to create, combine, filter, and new observables from scratch or using existing observables. I believe everyone who worked with reactive frameworks would agree with me that these frameworks are useful mostly because of the operators they provide. Reactive frameworks, they are really popular nowadays. We have, for example, Rx.js, which is very famous in the web development community. We have Rx.java, Rx.net, Rx.py, Rx.cpp, and etc. And all of them, they share the same ideas and concepts. And reactive programming is mostly used, for example, in user interfaces, message-driven applications, web servers. But in areas such as machine learning, reinforcement learning, data also often arrive asynchronously and at different timescales. And it is very important to have a framework to deal with such data streams. In our lab, we use reactive programming for online signal processing, for example. And Julia already have some implementations of reactive programming concepts. There are reactive.jl or signals.jl. There are good packages for sure, but they're not really reactive frameworks because they do not implement these general concepts of reactive paradigm, such as subscriptions or listener or a lazy evaluation, where you do not provide a lot of operators to work with streams and so on and so on. And our new package, Rocket, for reactive programming in comparison with the other implementations has some advantages and extra features. First of all is the performance. Rocket has been designed to be efficient as much as possible. We do much better in terms of execution time and comparable with other packages in terms of memory consumption. Reactive paradigm itself inevitably introduces an additional level of abstractions. But with the help of Julia's type system, multiple dispatch, and advanced optimization techniques, they can be evaluated and inlined at compile time. And it results in an efficient implementation of reactive paradigm with almost zero overhead compared to traditional imperative programs. The second one is the flexibility. It is very easy to extend functionality of Rocket, for example, to add a new operator or a new custom observable. We have a sections in documentation for that. Rocket provides a rich set of built-in operators for composing, merging, filtering your streams of data, and to react accordingly. And it uses a convenient macro-free syntax with a pipe operation. There's also a very little performance difference comparing to the built-in Julia functions like map or reduce. Of course, for some operators, there will be a performance difference. For example, for count operator, which just counts number of data emissions in an observable, before completion. And therefore, a static array, you can just call a length function. But in some sense, it is also one of the features of reactive frameworks that they provide the same API both for static and for dynamic asynchronous data streams. And for example, if you have some code for signal processing from your sensors, and you want to test it, you can just replace your data stream with a static array, and you don't have to change any single line of your code. Here, for example, how you can apply a map operator on a data stream using a pipe syntax. Some operators like map or reduce or scan, they need a return type specification as a first argument. And here, for example, a filter operator, it doesn't change the type of data in an observable, so we don't specify it here. And of course, you can use a composition of different operators. The next feature of Rocket is that we support error handling and completion events in the data streams. We work with typed observables. It means that if you do something wrong, it will probably fail at compile time and not in runtime. We support lazy evaluation for observables, subscription, and unsubscription. We have scheduler support for both synchronous and asynchronous data streams. Synchronous streams use a built-in Julia task object. We also have an experimental thread scheduler to be able to execute an observable on a different thread. And yeah, the last one is a comprehensive and self-contained documentation. We have spent a lot of time on it, and Rocket has a rich set of examples for every built-in operator or observable. It also, as I already said, it has a section of how to extend functionality, how to create a custom observable or operators or actors. And of course, it is available on the GitHub under MIT license, and everyone is welcome to contribute. And yeah, this is basically it. Thank you again for the opportunity to present. I will be happy to answer any questions.